Well, hi, good morning. Thanks so much for joining me here in my shop for a little bit of a late start. Partially because I don't really know what I need to do about this radio. So, what you were just listening to is the one and only station that it receives, not unlike most radios here in my shop. The noise that came with it, the interference, the heterodyne, the tones, the whistle, but not the clicking, is all from my computer. Because I came in this morning, decided before turning anything on I would turn the radio on, just to see if there's some chance that the whole experience I'm having with it is really related to just interference coming from, well, my computer. My computer and a couple of computer screens I have right in here. And what I could hear is this radio station and that clicking interference. Ticking. But none of that heterodyne. So all that heterodyne has come from the computer. Of course, no surprise in this. The result of doing that is I'm just continue to be convinced that the radio is not performing the way it should, doesn't have the volume that it should. Wow. I'm not sure of anything, frankly. One part of the alignment process I didn't bother checking or experimenting with yesterday was one of the capacitors on the side, one of the trimmers on the side of the tuning capacitor, because it's not accessible. So I think right away, now that I've stripped off all the equipment here, I've taken off all the connections, I'm going to lay the radio down properly, and we're going to give it a try that way. Well, that didn't help, just setting it down. Trimmer, capacitor, trimmers are down here. Again, it's really a long shot that this is causing the radio to be super weak, but who knows? I don't know. One of these two capacitor sections is for the oscillator and the other is for the receiver. Let's see if we can figure it out. Hello. So this is the section with the switch, if you like, on it. It shows it here as the antenna section, shorted at maximum capacity to allow phono operation. There's a little bend in the plate there. So this is it. That's the trimmer we want to try. Oh, is it much better already? I haven't done anything. Okay. So I'm doing this with a station. Probably be done at the top end of the band, not the bottom. Back that out a long ways. It seemed to help. Like a lot of these radios, it seems to be the trimmers have to go right out to maximum, as if the peak is beyond and you can never get there. Seems to be the case with a lot of these radios. What I wanted to look at was what? I don't know what I'm looking for. Hey, I'm off to a great start here today. Well, let's do the proper. Yeah, that's right. I was going to read the proper method down here. Let's do this properly. We'll go through the alignment process properly and just see if that doesn't somehow magically resolve the situation here. So we should really start with the IF, which I sort of fooled with yesterday, but I think I'm going to want to tune it properly today. So we'll set up for the IF. 455 is the frequency written here. Nominal, this is interesting here, nominal sensitivity, 50 milliwatts output. So to get 50 milliwatts at the speaker, you should be providing 1200 microvolts to the antenna. No, to this pin. Why don't we see if we can do this? Find out what's happening. Now, how do you know 30, or is it 50? 30 or 50 milliwatts output. How do you know that? Well, that's a good question. Can't say I've ever actually tried to measure the output in milliwatts. 50 milliwatts. Okay, I got to think about that one a little bit to figure out how I can determine there's 50 milliwatts on the speaker. It might just be a little simple calculation with the speaker impedance. I'm not sure. Being lazy, I just typed into Google a couple of words and I got this table here. Quick conversion chart of milliwatt per volt to volt per ohm. That's handy. So 50 milliwatts per volt in volts per ohm is 0.05 volts per ohm. Now if we assume that's a, well, let's use 10 ohm speaker, then that makes an easy calculation at 0.5 volts. 0.5 volts is going to give you 50 milliwatts. We should be looking for something in the range of 0.5 volts on that speaker. 0.5 volts. Now what do I want to try to measure that with? My troublesome meter? Let's use the troublesome meter. 0.5 volts on this meter would be, so we're on the 1, this is 0.1, so I really want this to be up here. Let's say 0.3, this would be 0.3, still not enough, up to 1. Okay, so this would be 1, 0.5, well, this would be direct reading at this point. We put this on 1, direct reading, so 0.5 is straight up. Hey, it's there right now. Okay, now it so happens that in this radio, according to this, the speaker circuit itself, voice coil circuit, not grounded. Now is that really the case in here? It's going to be, what else am I going to have connected here? I'm going to be wanting to feed a signal from the signal generator into the radio. I'm going to be careful about the grounding. I need to know if that speaker voice coil really is independent, the chassis and everything. Because although it shows it free on the diagram, it's not necessarily the case, I have discovered. So we'll just check one, really just one side here. Yeah, open circuit. Good. Okay, so that means it is totally isolated. Very good. So I can have the ground from here connected, and let me get all my equipment set up here, and then we'll start doing this. Okay, just about ready here. I had to give up on that HP meter, and so I brought down this this meter here. Where's the name of it? Ballantine meter. So we're gonna, the other meter was always showing a voltage even with no leads plugged in, so I don't know what's going on with it. Every time I try to use it, it doesn't, almost every time I use it, it really doesn't work out. So we're on the 1 volt scale. 1 volt is here, half a volt is about here. So that's kind of where we want the output to show up. I've calibrated my signal generator. It's putting out 100 microvolts. Just exactly what's on the end of the cable here. A little bit debatable. I suppose I could try measuring it. It's a fairly low. That's an interesting idea. I've never really tried that. I think this guy will go up to 10 megahertz, I think, or at least 1 megahertz on the AC scale. So we might want to try that. Why don't we try that right now before I turn the radio on? A good idea. Okay, we're just gonna hook them up here. Set this to AC. I may be wrong about the frequency response. It's 200 millivolt scale. I'm expecting, oh, I'm expecting 1,000 microvolts. 1,000 microvolts is 1 volt. Is that right? 1,000 millivolts is 1 volt. 1,000 microvolts is 1 millivolt. 1 millivolt. I don't think it's going to show up here. This would be 200. Why is the decimal point where it is? I can never understand my own meters. Let's try something. Let's try using this meter. Let's try this. Again, I've never tried this. So that's 1,000. Is that really the output? This is kind of interesting, actually. Okay, I'm going to vary the output downwards. It didn't do a thing. Well, trying to tell me that. Let me short this out. There's that much voltage just on the wire, just from interference. And that doesn't go away when I plug into here. Let's go direct here. Just 1 sec. So this little box is an antenna simulator. My understanding is, use this box, the signal generator will see 50 ohms and the radio will see around 250, depends on the frequency you're operating at. When I hook this meter straight to the output, I would expect to see the output level, or it will just fall to nothing. Shouldn't be floating around like it was. I mean, we're getting the right results. I gotta kind of wonder what's going on with this box, which I use all the time. It has a capacitor in it, which is just a little extra safety for hooking up the signal generator to a radio in case you make a mistake. And flash your signal generator with a big DC voltage. That would not be good. Okay, well, let's assume now this is actually reading the voltage coming out of here. Let me go up by a factor of 10. And another factor of 10. we'll go down, factor of 10. And we're seeing something. Oh, I've got this turned right down. Oh, look at that. There we go. Let's go back down. Calibrate this way. It might even be better. So we want to put in a signal, it said, of 1200 microvolts. So 1200 would be 10 times 100. This would be 1200. So we're on the 0.01. Will help me please. Volts full scale. 0.01. So this is 0.01. So we're way low. I would say we're way low at this point. This is 1200. Now there's another control here that maybe I need to move. That doesn't make much difference. Okay. What do you think of this? I'm not sure what to think of this. Using a modulated signal. Let's get rid of the modulation. This is reading the calibration up here, which is where it's supposed to be. So it's 10 microvolts times a multiplier. 10 times 100 is 1,000 microvolts. 1,000 microvolts would be 0.001. 0.01 is here. 0.001 would be here. We're right around 1,200. I think that's what this means, just by some luck. So it thinks it's putting, according to the settings here, 1,000, and this is reading 1,200. Well, I think that's close enough. Who would you believe? Now if I stick this box back in there, it's goodbye to what we're getting here. I'm pretty sure. Let's just give it a try. It's just picking up because it's almost like it's open circuit. Okay, so we're going to do this test. I'm going to rely on the, yeah, I really shouldn't have this box in unless I'm hooking up to an antenna, really. So I have a capacitor here sticking out of the radio, and that's tied to the, as instructed here, pin 1 of the 12BA6. Pin 1 of the 12BA6 is going straight to the grid. We're going to feed in 455 into the grid of the tube ahead of this transformer. So we're just kind of operating this part of the radio. The rest of it, not involved. That's the idea. Okay, so we'll go back to put this back on audio. What's it doing way up there now? Yeah, because I have this like this. So 1 volt is full scale. So 0.5 volts is what we're aiming for with the level of signal I have this set to. If all this works. If okay, and in the end it's not going to work, and then I'm going to be scratching my head. Yeah, what exactly is not working? Is it the radio or is it my setup? That's always the problem here. So I want this to go onto the B minus. We're going to pick that up right here. Okay, and we want this to not pull that. I had a heck of a time making this clip stay in here. It's really very, very fragile. Tried a couple different clips. Is this going to pull it off? No, it's not going to pull it off. Okay. Oop, wrong control. Let's turn on the radio. There we go. Now if I turn the volume up, there should be enough stuff coming through to make that meter go up. I would think. Unless 50 milliwatts is screamingly loud in that speaker. Again, you can hear the radio performing better just before it finished warming right up. I mean, that's a strong indication. That's a very strong indication something not right. I don't know if I need to do all these tests. Okay, so we're getting nothing on the meter. Nothing on the meter. Come down. Oh, this must be with the volume turned up full. Set gang at nominal sensitivity. Yeah, well, it doesn't actually say, but normally you're doing all this work with the volume up full. Ah, diggity dog. That's that's not how I like to do these things. Okay, so if we go here, when I connect the signal generator, it's quite likely to knock that sound out. So let's do that. I'm going to turn down the signal generator with this. Okay. Oh, that's much better. Turn it up. Okay, so I turn this guy back up to the times 100 setting. This thing should come up to the 0.5. Then it's thumbs up, everything's great. Just barely hear it. Is it me? Is it it? Is it me? So this is suggesting at this point, if my test setup is correct, the radio is very insensitive under this test. Let's go another 10, and I think we'll see the meter come up where it needs to be. No. We have no modulation. That shouldn't matter. Wow, it is blasted here. Let me turn it down with this. Turn it up. This never came up. This can't come up. This can't come up. It's no audio. I mean, it's showing us what we're hearing. Signal generator modulated 30% at 400. Okay, we'll do that. Back down. 30% at 400. Yeah, this makes more sense. Sounds like a lot of leaky capacitors inside that signal generator. Okay, now we're getting somewhere. Now we are getting somewhere. So we're putting out, according to this, 1,000. According to the meter measurement, around 1,200. Okay, volume is up all the way. We're getting very close to half. A volt. Although it sounds bad. Okay, what are you supposed to do at this point? This is what you're supposed to get in the end. Tune the transformer under these circumstances. I think I'm putting way too much signal into it, but let's go ahead. Second transformer, let's not make a mistake. First, second is close to the output tube. Second is close to the output tube. That's down here. You know what? I'm just going to turn this down. We don't need it up like that. Do this. Good. Okay. Right from there, because it's just blasting my ears. Here we go. Down. So that's right on the money. Okay, we'll do the underside here. This is the one we can't get at with a little screwdriver. think I did. Turn the wrong one. Okay. Let's turn the right one. Wait 1 second here. Wait a minute. That is the right one. Why do I see nothing happen? Oh, what did I do? I don't know. Maybe I don't know. Okay, make this guy go maximum. That's pretty much where it was. Okay, so under this test arrangement, with everything done right, the result is just under 5. Just under 0.5. Very close to what it's supposed to be. Now if I wanted this to actually put out 1200, it'd take me a little while to get that set so it thinks it's putting out 1200. So I'm not going to try that. It's easier to just go 1000, 10,000. Close enough. So I think this indicates, to me, oddly enough, the output from this part of the radio forward is fine. I'm going to go right back to, is there anything wrong with this radio? Okay, so we'll follow the next step. 12BE6 pin 7. This time we're down around 40. So if I go from 1000 to 100, let me do it right now. Go down. That'll be 100, and then if I set this to 5, that's going to be an input of 500. No, wait, am I supposed to be more like 40? Not 500. Okay. So this is set to 5. This times 10 is 50. Yeah, no, that's correct. That's where it should be, right around there. Trust me. Okay. Now I'm going to move this to another location in the radio. The second one, we're going to pin 7 of the 12BE6. Okay, power off. During this little operation, pin 7 of the 12BE6. That's this one here. Pin 7 is right there. Easy to find. Don't want this to suddenly move around when I'm not paying attention to it. This radio really resists having clips put on it. That's good. There we are. Okay, got something solid there. And we'll disconnect here. No, we'll leave it connected because I don't want all that noise coming out. In fact, I'll turn the volume down to start. Power on. Goes again. Sounds like it's strong, and then it's coming back. Could be all this stuff. I don't hear my signal generator at all. Why is that? Go up. 500. A couple possibilities. I picked the wrong pin. 12BE6 pin number 7. No, that's correct. Okay, so it's supposed to be 40 to get it up to here, and I got 400 in there right now. So this suggests this stage is weak. I don't believe it, but let's go ahead and we'll adjust it. Double check. Change my little thing. First IF. Okay, watching the meter. This is the one I think this is the one I found a little out yesterday. And on the top. Okay. What's up here? What's up here? So we have this set to 5 times 100. 500 microvolts. And we're getting a signal. We're on the 0.1 scale, so this is what it really looks like. The volume's up. Is the volume up? No. Is that meter reacting to all this noise? Let's find out. Okay, what I'll do is I'll cut away the modulation and see if the meter reacts. Kill all that noise. I might be able to do that. If I kill the antenna signal, let's try that. Let's see if we can get rid of it. Do the thing. Nothing. Okay, another way is to tune. Tune this until that switch thing. That's it. That's the switch. Not getting rid of much of the noise. Well, it's pretty clear. This reading is from the audio. Okay, here we go. 1 volt. Cover your ears. Up over it, way over the 5. But that's with 500. If we put this on 50, can't even hear it. Supposed to be able to put 40 microvolts onto the pin here and get 50 milliwatts at 0.5 on the 1 volt scale here. Wow, okay. This is not the best. It's not the best thing here. This is not the best thing. So I'm going into the 12BE6, out of the 12BE6, through the rest of the radio. Most of the rest of the radio has been proven to be okay, supposedly, by the test I did. So something between the injection point and the previous injection point is not right. And what's there? There's a tube and a transformer and a few components. The tube is the obvious target. Now I put in a better tube there, at least I thought I did. So now I got to start over with that. It seems like I've localized the issue to here. Unfortunately, something to do with this tube, something to do with this transformer, something to do with the circuitry just around here. Feed the signal in at this point, the radio seems to amplify it the way it should. Feed it in back here, no. We don't get what we want. Yeah. When I tune this transformer, there seems the primary and secondary, there seems to be a peak. I would suggest to me capacitor is probably okay inside. Coil's probably okay. If this coil were open, we have no B plus on the 12BE6. But I've seen from previous measurements there's 75 volts there or a little more. Second, now primary side can go open because bad things happen in these radios and they draw heavy currents through the tube and through this coil and burn it. I've encountered that. I don't think I've ever actually encountered that actual event taking place. Secondary side, there's really not much pushing or pulling on it. Not likely to have opened. The most likely thing is the tube, for sure. So, okay, I'm going to give the tube a little more time to cool off. I'm going to cool off. Test that tube again. Okay, ready to test a 12BE6. This is set up, but let's double check. 13 volts for signal level 8L 51763. 51763. 3000 3000 41. Whoops, didn't do that. C, didn't do this. Okay, now we're ready. These are the original tubes here, these three that are laying here, that I replaced, including the one I'm testing now was a replacement. Okay, check for leaks. Nope, no shorts. This tube should test 1570, so 1500 is right halfway up. Look at that. Not the tube. Not the tube. Boy, oh boy, oh boy. Well, let's just consider this for a little bit, and then I think I'm going to stop for today and ponder my next move. So what we're finding here is, if you feed the signal in here, it seems to be okay. It didn't sound great to me, but the signal strength seemed to be okay. Feed the signal in here, not okay. way off. Tube itself seems to be operating fine. What are we left with? Shorted capacitor here. Basically finding a ground here. Now how would that that would perhaps, it was bad enough you would have trouble feeding the signal into this tube. That's far-fetched. Like a capacitor. It's coming out of the tube. Okay, I guess that's something I can probably look at and make a judgment about. If it's coming out of the tube, okay. And it's encountering this. Oh boy, if it turns out it's the IF transformer itself. For somehow, some way, that's bad. That would be bad. So I think maybe tomorrow I'm going to pick up with trying to identify the quality of the output coming out of this tube, what's being fed into this transformer. And try to look more closely at this thing's operation. Don't like it. I don't like where this is going. Or am I still just chasing a ghost? I don't think so. Well, thanks a lot for watching. And we'll see what happens tomorrow.